Hi there children, welcome back to the online class. As you had been seeing, we had been doing matrices in the previous session. We checked with the what is the basic definition of matrices. We went into how to construct a matrix, and then finally we went into how you do the operations on matrices. We did do some examples based on operations, specifically addition, subtraction and multiplication of matrices. Now all this part we had already finished up in class 10. So I would just put across my word that this is just a recapitulation of what you have done in class 10. But now from now onwards you are going to study something which is very relevant for your class 12 syllabus. So let us begin with that particular thing. So having said that, we are going to, in the beginning, we are going to touch small concepts, and once those concepts are ready in your mind, then we'll go venture out to the bigger part of the matrices. So let us begin. The first concept I want you to understand and know is nothing but transpose of a matrix. Now this is very interesting fact. Let us put about transpose of a matrix. Now what you mean by transpose? You must be having an idea. When the row gets interchanged with columns, I say the transpose of the matrix is done. So I can just put a small wording here that row interchanges with column. Rows interchange with column. This is the first thing. So let us see what is exactly how it looks, how it behaves and all those things. Second point, as we go on, so let us take an example, say A. I give you a matrix, say 1, 2, -1, 3. I just took a very unique element so that you understand what is it exactly. Now you all know that this is row 1 and this is row 2. This is column 1 and this is column 2. Now having said that, row 1, row 2 and column 1, column 2, if I make this row 1, if you see this row 1, 1, 2, make it column. So how I go ahead, just see, just pay attention. So what happens is, suppose this is the matrix A, I want to find the transpose of this row 1, 2 will become column 1, 2. You can see this row 1, 2 became column 1, 2. Similarly, row 2 became column 2. So this will become -1, 3. So row 2 becomes column 2. So this is exactly the transpose of any matrix, whether it is a 2 by 2 matrix or 3 by 3 matrix. Second point, very important, I want to share with you is this transpose is actually denoted by A dash, or you can also say AT. Understand these points. So this is what exactly what I mean by transpose. Now something, let us go a little bit ahead. Now I got a matrix here, I got a transpose here. Now I want to take you further to transpose of transpose. So this is the matrix here. So I want to find the transpose of the transpose here. So what does that mean? Let us see this. Look what is happening. Okay. So what happened? Now I show this row 1, 1 minus 1 will become column, and row 2 will become column 2. Now what you see, connect these two things. These two are the same matrix. So in short, I want to just share with you that when a matrix happens to be A, okay, you find the transpose of it, and transpose of transpose. From here, if I say transpose of transpose, gives you the original matrix I had shown you over here. So a transpose is there, right? I find the transpose of a transpose is the original matrix back. So this is considered as one of the property which will help you in solving the sums later on. This is one. Second point, one more property, two more properties are there. A plus B transpose can also be given as A transpose plus B transpose. So you might ask me, sir, what is this property is about? What it helps us in? This property helps us to work on the sums in a better way, in an easier way, in a simplified way. So that's why these properties are relevant. Okay. Next property is slightly important property. Third property, if suppose AB transpose happens to be. So it doesn't happen A transpose into B transpose as you did with plus and minus sign. This is always B transpose into A transpose. So these three properties are there which are important. Number 1, number 2, number 3, and just keep that in mind. And what do you exactly mean by transpose? And transpose of a transpose, I proved my point. This property over here, it gives me the original matrix. Okay, so right now out of this, what you need to focus is what do you mean by transpose, how we do the transpose. Then these three properties you have to keep in mind. So please pause and note it down. We'll take the next part of the concept right away, that is symmetric and skew symmetric matrix. Take it on, please, children. So let's take the next part of the concept. After seeing what do you mean by transpose and seeing the properties of transpose, let us see the concept of symmetric and skew symmetric matrices. Having said this, I'll just show you one example. I think with an example it will be better, you will be privileged to understand what is symmetric matrix. It's something new which we have not done in class 10. Suppose I have a matrix A, okay, just understand what I'm doing, 1, 2, 2, 3. Now, you already know what you mean by a transpose, right? So, let us get a transpose of A. So, transpose of A, that means this row will become column. Second row will become second column. Now, I want you to make a comparison between the matrix A and its transpose. Can you have a look of it? I want you to make a view of this matrix and its transpose. What do you see? You see that even though I did the transpose, the matrix remains the same, 1, 2, 2, 3, 1, 2, 2, 3. So whenever, keep that in mind, whenever you have a matrix is equal to its transpose, then it is nothing but a symmetric matrix. So when a matrix is equal to its transpose, it is called as symmetric matrix. Okay, fine. Now similarly, what is a skew symmetric matrix? Keep that in mind. Skew symmetric matrix I will put across this way. When a transpose of a matrix is equal to minus of that matrix, then I say it is skew symmetric matrix. I repeat, when a transpose is equal to the matrix, it is called symmetric. When a transpose is equal to negative of that matrix, it is called as skew symmetric matrix. Now, what is the importance of it? How we understand, how we get to know about it? So, I'll just put across one particular example for you all. Basically, a particular type of sum will come up. I'll be giving you an example, okay, and then I'll just mention a property. But I can mention the property right away also. So just note it down. Write down sum of symmetric and skew symmetric. Now, this part of the question had come in the board exam. They express a matrix as sum of symmetric and skew. We will see the example how we do it. Skew symmetric matrix. It is given by the formula that is half A plus AT, this is the symmetric part, plus half A minus AT, give you matrix A. So, you are expressing a matrix A as sum of symmetrics and skew symmetric, okay, symmetric and skew symmetric. So, this is a very important formula if in case the sum comes on this pattern of the sum, that is on symmetric and skew symmetric. So, understand this is the important rule or property for symmetric when a matrix is equal to its transpose. Similarly, when a transpose is equal to the negative of the matrix. So, these three things you have to remember, 1, 2 and 3. So, I hope you are getting the working of understanding the part of it. So, this is a short way. Now, we will see some examples based on transpose, symmetric and skew symmetric. It's a very, very short exercise. Very few examples are based on this. So we'll just touch those and just to understand this concept better. Okay, children? So pause and note it down. This is an important question here. So I had given you a matrix A and matrix B, and I am telling you all find AB transpose. So one mechanism would be to find AB and then its transpose. And next mechanism will be I can use the properties of AB transpose, which I shared with you just recently. AB transpose is nothing but B transpose A transpose. Now the other way of putting this question would be verify whether AB transpose, or say whether verify AB transpose is equal to B transpose into A transpose. So both way I will show you, and we will not only verify but you will find the quick answer for this also. So let us start with this question. Now they are specified very clearly that AB transpose. So first method is, okay, you get AB and find the transpose. So let me get AB now here. So AB, you know what is AB, right? You multiply the row into column from the first matrix to the second matrix. So let us see what happens. 2 4s are 8. Now remember this row and this column. First row you have to multiply with all the columns, which we had seen in how to multiply the matrices, and let us get this part clear. So AB, that is first row, first column. 2 4s are 8 plus 3 plus 0. So 8 plus 3 plus 0 is nothing but 11. First row, second column. 0, 6 plus 4 3s are 12, 18. Then the first row, third column. 2 5s are 10, 0, 4, 14. So first row you had multiplied with all the columns. Now you will take the second row. So second row, 5 4s are 20, 7 1s are 7, 27. Then 5 0s are 0, 7 2s are 14, and 9 3s are 27. Understand? 7 2s are 14, 9 3s are 27. 27 plus 4, 31. So this will become 41. Check it once again. 5 0 are 0, 7 2s are 14, 9 3s are 27. 27 4, 31, 41. Then finally second row, third column. 5 5s are 25 plus 9, that is nothing but 34. So you finished with the multiplication of the second row with all the columns of the second matrix for AB. So finally children, the third row is left out now. Minus 8 plus 1, that is minus 7. Similarly minus 0 here, 1 2, 2 plus 3, answer is 5. Third row, third column, minus 2, minus 10, minus 10, 0 plus 1, I think it should give you 9. Let me have a confirmation. Minus 10, 0, 1, I find it. AB, I got it. Now they are telling us find AB transpose. So my first method is find AB, product and transpose of that. So what is the transpose of this now? So I can get AB transpose as, understand what is happening, row will become column. Row will become column. So this row will become column. So 11, 18, 14, then 27, 41, 34. Second row becomes second column, and third row becomes third column. So this is what is transpose. Now as I said, I supported this is the next question, that find AB transpose. Instead of, or say verify AB transpose is equal to B transpose into A transpose. So we can do both. Verify means it just prove. So I got one way of doing this. The second is finding AB transpose by using the properties. That also you can work out. Now how we do about it? Now you know that AB transpose is nothing but B transpose into A transpose. Do you agree with this? Let us see how we go. So B transpose. So I am just writing the matrix here. So B transpose and A transpose. Now let us see B transpose. Now remember, AB transpose is not A transpose into B transpose. It is B transpose into A transpose. Reverse. So let us write the B transpose now. So 405. The first row will become the first column, 405. Then 1 2 0. then 0, 3, 1. Similarly, A transpose 2, 3, 4, 5, 7, 9 and minus 2, 1, 1. Now, as you're going to multiply these two matrices, so let us just go with the multiplication now. So, I just put across here. So, how you multiply? As you did over this side, first row, first column. So, 4 2s are 8 plus 11. So, this is 11. First row, second column, 4 5s are 20, 7 1s are 7. So, 27. 4 into minus 2, I believe first row and third column, minus 8 plus 1, minus 7. 0, 6, second row, I am taking the second row and the first column, 0, 6, 12, 12 plus 6 is 18. 0, 14, 9 3s are 27, try to understand. For 0, 2 7s are 14, 9 3s are 27. 27 plus 4, 31. So, this is nothing but 41. Similarly, 0, 2, 3, 5. So, second row is over, third row, try to understand. 5 2s are 10, 0, 4, 14. 25, 0, 9, 34. Minus 10 plus 1, minus 9. Now, compare. 11 27 minus 7, 11 27 minus 7, 18 41 5, 18 41 5, 14 34 minus 9, fine. So, both the points remain the same. So, this is nothing but B transpose into A transpose. Now, from here I can confirm to find AB transpose. So, in short, a property has been verified unknowingly, that is nothing but AB transpose is nothing but B transpose into A transpose. So, there is a question here which comes up, find AB transpose, you just use any method this way or this way and go for it. But in case they put you a question, they modify this question, they will say verify AB transpose is equal to B transpose into A transpose, then what you are supposed to do? You do the LHS working here, do the RHS working, prove that they both are equal. So, this is what exactly the sum based on transpose comes up for you. So, I hope you got this point clear, children. So, pause and note it down. Hi there. So, this is the next example following the transpose of the matrix. So, you remember symmetric is nothing but when a matrix is equal to its transpose, it is symmetric matrix. When a transpose is equal to negative of that matrix, it is called as skew symmetric matrix. So, children, let us see this sum. This question I am just covering both of them because this has the property. If you remember the property, I told you that a matrix can be written as sum of symmetric and skew symmetric, that is A plus AT, A minus AT. So, half of A plus AT plus half of A minus AT. Anyway, that sum I will just share with you also, that example. But these are very simple examples now. First thing I want to understand, they are telling us to prove that A plus AT is a symmetric matrix. Now, what is exactly A plus AT and what is exactly A minus AT? Okay, A plus AT is nothing but a matrix plus a matrix. So, that means a matrix plus a matrix, that means you have to prove the resulting matrix is a symmetric matrix. Are you understanding my point? So, remember A plus AT, you get a matrix. So, you have to prove that matrix is a symmetric matrix. So, when that matrix will be a symmetric matrix? When that matrix is equal to its transpose. Okay. Now, for example, A plus AT you give you a C matrix. So, if I want to prove that C is a symmetric matrix, what it should prove? That C matrix equal to its transpose, then C is called symmetric. And what is C? A plus AT. So, do not get confused. Similarly, A minus AT, take it a matrix minus a matrix will be a matrix C, for example. Now, C I have to prove it is a skew symmetric matrix. Skew symmetric matrix means what? A transpose is equal to negative of C. So, transpose of C is nothing but negative of C. So, that is the property. Anyway, I will just share with you, when you are working it will get cleared better. Let us take this example now, A plus AT. So, I believe first you find A plus AT in this case. So, let us see what happens. A plus AT matrix. So, A plus AT. So, I will just get this point here. So, A matrix plus transpose of A. So first row will become the first column, 1, 2, then 3, 4. Okay, so I got, now matrix plus matrix will be another matrix. So let us take this as C. Okay, so I will just put C as 1 plus 1, 2, 2 plus 3, 5, 3 plus 2, 5, and 4 plus 4, 8. So I got C matrix. Now they are telling prove that this matrix C, which is A plus AT, in other words, prove that it is symmetric. So you all know when a matrix is symmetric matrix, when A is equal to its transpose. So in short, I have to prove C is equal to its transpose. Keep that in mind. So what is the transpose of this C? Let us see this part. So C transpose is nothing but, so first row will become first column, 2, 5 will become 2, 5 here, and 5, 8 will become this thing. Now if you carefully observe here, C is equal to CT. But what is C? C is nothing but A plus AT. So it is A plus AT matrix is equal to A plus AT transpose. You are understanding my point? So you have proved a matrix C is equal to its transpose. What does that mean? It means that this A plus AT is a symmetric matrix. So I hope you are getting my point very clear. So similar approach for A minus AT for skew symmetric. So everybody knows when a matrix is a skew symmetric, when transpose of a matrix is negative of the matrix, then it is skew symmetric, right? So first thing you have to get A minus AT, because you don't have to prove A is a skew symmetric. They are asking prove that A minus AT is a skew symmetric. So when I say A minus AT is a skew symmetric, what does that mean? It means that A minus AT, one matrix you get, let us take C, you can take a D, no problem at all. So that D matrix should be a skew symmetric. When D will be a skew symmetric? When transpose of D is equal to negative of D. So let us see this sum, how you go about it. Okay. So A minus AT. So let us get A minus AT first. So A matrix is already given to you as I given on the left hand side, 1, 2, 3, 4. Okay. Then minus AT. So AT is nothing but 1, 3, 2, 4. So let us get this D matrix. So I'll just mention it as first. I'll just get the subtraction of it. So this is 1 minus 1, 0, 2 minus 3 minus 1, 3 minus 2 is 1, 4 minus 4 is 0. Understand? So I'll just take this as say D matrix. Okay. Now D is nothing but A minus AT. Now I have to prove D is a skew symmetric. When D will be a skew symmetric? If and only if D transpose is equal to minus D. Try to understand this. So let us get the LHS first. So if I want to find the LHS, transpose of D. So tell me what is transpose of D? First row 0 minus 1 will become 0 minus 1 column, then 1 0. Now let us get the minus of D. D is already here for you. So get the minus of this. So this is 0, this is 1, this is minus 1, this is 0. Now check what is happening between these two parameters. They are equal. That means what I proved? I proved dt is equal to minus b. What is d? D is nothing but A minus AT. So when I prove a transpose is equal to negative of a matrix, it means that A minus AT is a skew symmetric matrix. So this is one of the very basic example to make you understand the concept of symmetric and skew symmetric. Remember these two important rules, properties. This is very important, 1 and 2. Okay, A minus AT, I mean to say this one. Okay, A is equal to AT is nothing but symmetric. Transpose is negative A, it is skew symmetric. So I hope you got this point clear. So I just want you to just copy it down, children. So pause and note it down. Hi. Now this is the next example on the symmetric and skew symmetric. You can see the question here. Express the matrix A is equal to 2, 1, 3, 1, 1, 4, children, minus 1, 6, 2 as the sum of symmetric and skew symmetric. Now this is the point, sum of. This sum had come in the board exam once. Okay, so sum of symmetric and skew symmetric matrix, and verify your answer. Verification is simple part. Let us focus on the first part. Express this matrix as sum of symmetric and skew symmetric. If you remember the property which I explained to you, sum of symmetric and skew symmetric is nothing but, you remember this, half A plus AT plus half A minus AT. If you remember this property which I explained to you when we were doing the symmetric and skew symmetric matrix. So that's what exactly we have to do this part, you have to do this part, combine them, and you get this working done. I hope you got this point clear. So let us begin this particular solution for the sum. So how I go about it. So first thing what I want you to understand is, as I have to express a sum of symmetric and sum of the symmetric and skew symmetric, just get it down here and that's it. So let us see this part. So half A plus AT. Now if you look at this, A matrix is given to you. So 2, 1, 3, right? Just a second. Okay, 2, 1, 3, 1, 1, 4, minus 1, 6, 2. Okay, now remember what I am doing here, just want to make you understand, it is half of A plus AT. Okay, so let us do that part. So plus AT. Okay, now I just put across this bracket as it is, will become, so AT means transpose of this one. So 2, 1, 3, first row becomes the first column, then 1, 1, 4, then you can see this minus 1, 6, 2. Close this operation, this is the way. So now you just get this working done. So half of what happens over here, remember this, what I am trying to do is I am trying to get half of sum of symmetric matrix, that is half of A plus AT plus half of A minus AT. So this part I am working over here. In fact, when you want to show, you have to show everything together. So if you want, I will just begin with that. So what is this point? Let us see this clarity on this. So what I will do, plus half. Okay, now half I got it. So plus half, that is A minus AT. Okay, so what I'll do, I'll just work out simultaneously so that you understand exactly what I'm trying to do. So that is A minus AT, copy the matrix A here. So 2, 1, 3, 1, 1, 4, minus 1, 6, 2. AT is 2, 1, 3, 1, 1, 4, and finally you get minus 1, 6 and 2. So what I did, just understand, this was half of A plus AT, this was half of A minus AT. So I am adding those things. So sum of symmetric plus skew symmetric. Now let us begin the working here. So what happens in this case is, this will become 2 plus 2, 4, right? 2 plus 2, 4, 1 plus 1, 2, 3 plus 3 minus 1 is 2. So 1 plus 1 is 2, 1 plus 1 is 2, 4 plus 6, 10, then minus 1, 3, that is 2, 6 plus 4, 10, 2 plus 2 is 4. So this I got combined form. Then plus, I am just writing this in a separate way, plus half. Now this is a subtraction of two matrix. Now if you see this, 2 minus 2, 0, 1 minus 1, 0, 3 minus of minus 1 is 4, 1 minus 1 is 0, 1 minus 1 is 0, then 4 minus 6 is minus 2. I am just doing the subtraction, nothing else. So minus 1 minus 3, minus 1 minus 3 is nothing but minus 4, and minus 1 minus 1 minus 3 is minus 4, 6 minus 4 is 2, and 2 minus 2 is 0. Here you stop. The first question is answered, because they are telling express A as sum of symmetric plus skew symmetric. So this you have to stop. So this is the first part. You expressed the sum as one matrix, the difference is another matrix, and you just club it out. This is sum of symmetric plus skew symmetric. Now if you want to verify, if you remember the property which I showed you, I will extend this. If you remember this property, this is expressing a matrix as sum of symmetric and skew symmetric, and this gives you the final result A. So if you do this addition, you should get A. So that's the mean verify your result. So half A plus 80 plus half A minus 80 should give you A back. So let us see whether we get the verification process. I will just push across here. Okay, verification process I will push across here. So anyway, I'll just try to work it over here this side. Or anyway, okay, let's see this way. I think it's just one step actually. So well, I can take half common, no doubt about it. So if I take half common, what will be left out? Let us see. 4 plus 0 4, 2 plus 0 2, 2 plus 4 is 6, then 2 plus 0 2, 2, 10 plus minus 2, that is 8, and 2 plus minus 4, I believe 2 minus 4 is minus 2, and 10 plus 2 is 12, and 4 plus 0 is 4. So if I divide, what happens? It will become 2, 2 2s are 4, 2 1s are 2, 2 3s are 6, 2 1s are 2, 2 1s are 2, 4, minus 1, 6 and 2. Now, what I want you to understand is check this matrix and check A matrix. Look, 213, 213, 114, 114, minus 162, minus 162. So this is nothing but A matrix. That means this part when I operated on this, if you look at this part when I operated on this, I got the A matrix back. So sum of symmetric plus skew symmetric, this is the verification part of this working. So I hope you got this point clear, children. Very simple example. There is no need to practice more sums. Just understand, if they ask you only the first part as the sum of symmetric and skew symmetric, you have to do this much and stop. There is no need to verify. But as this question can verify your result, so I proved that sum of this is the property which is nothing but matrix A. So I got this matrix A here. Okay. So this is the working of the sum. Once it has come in the board exam, but I don't think so it will be repeated anywhere in the near future. Anyway, take it down, children, and just enjoy this question, please. Hello there, welcome to the online classes, and I'm very happy to present this topic to you after doing lot of relation functions. We are into some algebraic mode, algebraic part of the topic called as determinants. So basically, what is this determinant? I think in class 10 you had done matrices. It is very similar to that. I would not say very similar. It is similar in its look, but of course the operations are completely different. So what I suggest, what is a determinant? A determinant is nothing but arrangement of numbers or variables, so whatever stuff it is. Say for example, A, B, C, D, I consider it as a number. I arrange these numbers in rows and columns, in between vertical bars. This representation is nothing but determinant of second order. So similarly, you have determinant of third order also, A, B, C, D, E, F, G, H, I, in between vertical bars. So arrangement of terms or numbers in rows and columns in between vertical bars forms the determinant. The terms which are in the vertical bars are called the elements of the determinant, and the evaluation of this determinant is nothing but a value. How I get the value is by doing AD minus BC. Very, very important. So the beginning happened now with determinant. What is a determinant? A determinant is nothing but arrangement of numbers in between vertical bars in rows and columns, row 1, row 2, column 1, column 2, and these are called the elements of the determinant, and this itself tells you that this comprises a particular value. That value is nothing but AD minus BC. Don't say BC minus AD. So let us take that different mode of example. For example, suppose if I take an example here, okay, let me say if I take an example here, okay, so suppose it is 1 3 minus 1 2. I want to evaluate the determinant. What is the evaluation here? 2 plus 3. So the AD minus of BC. So it is nothing but 2 plus 3, answer is 5. So this is the first beginning. You should understand that when you evaluate the determinant, it happens this way, AD minus BC. So this is determinant of order 2. Okay, I hope you got this point clear. Now what we look into, what are the types of things we look into this determinant of order 2? Then we will come to order 3 and further concepts associated with this particular topic determinant. The type of sum which will come up might be of this nature. For example, suppose if I say evaluate this determinant if 3 2 x 1 is equal to 5, they will say find x. So tell me what you will do with this question. It will be nothing but AD minus BC is equal to 5. So minus 2x equals to 2. 5 minus 3 is 2. So x is nothing but minus 1. Don't mix this up with the absolute symbol. It is not an absolute symbol. Like matrices, you denote by square brackets. So this you denote by vertical bars. I hope you got an idea of order 2 by 2 determinant. So take it down, children. So if you want, we can write the definition here, write this is the elements. Nobody is interested in all that stuff. What you need to know is, how to work out that. So the first thing what I explained to you, how we evaluate the determinant of order 2 by 2, how the sum will come up into this nature. Is this clear? We will see 2-3 examples on this, right? And we will get back to it. So take it down. Don't commit mistake. Nice topic this is. You will have a good exposure on this topic. Okay. Yeah, it's I had mentioned to you all what is 2 by 2 determinant. That is, I mean to say order of determinant, order determinant 2. So we need how to evaluate AD minus BC. So I had given you just 3 examples under one question. Question number 1, solve the following, evaluate this. In this question, finding a particular value of m, and in this part I had complicated that, just making too many expressions. The procedure remains the same. So let us talk about evaluation of the determinant in this case. So everybody knows it is always AD minus BC. So AD minus of BC. So what happens? It will become 2 minus into minus 12. So the final answer is 14. So understand, very simple evaluation. So let us take the next part, the second one. If you see the B part, find the value of m if this is equal to 3. So if this is equal to 3, the value would be, I think you can just work out, it is AD, that is 5 3s are 15, minus 4m is equal to 3. So 15 minus 3 is equal to 4m. So 12 is equal to 4m, m is equal to 3. So these two clear. One is evaluation, finding the value of the unknown. The third example is also same line as this B1. So C question happens to be like this. So again AD minus BC. So AD, it will look like this, x minus 1 into x minus 3 minus of x into x minus 2. Be careful, it is AD minus BC. Don't do AD minus BC. AD is the diagonal this way, okay. So AD minus BC. So x minus 1, now open this up. I think there is nothing to get a clue here. So this is x square minus 3x minus x plus 3 minus x square plus 2x equal to 0. So what happens finally? I think we can eliminate this x square here, right? I need to find the value of x. So this is minus 4x plus 3 plus 2x equal to 0. So I think it is nothing but 2x equals to 3. So I get the answer as x equals to 3 by 2. So check it out, because minus 4x this side plus 2x this side. So 4x minus 2x is 2x. So 2x equals to 3. So this is a basic match it all. So this is what it is there in front of you. I hope you got this point clear, how to deal with the sums of order 2 by 2. Now this is the evaluation of order 2 by 2, AD minus BC. So now what is more important is how to evaluate or find the value of the determinant of order 3. Now that is very, very important, and we will be focusing on that very frequently and more importantly than this part. So just pause and note it down, and just have a good sign, because of a lot of time we are doing some basic mathematics, right children? Okay, take it down. Okay, here we go. As I said, we had seen how to evaluate the determinant of order 2. Now we will see how to evaluate a determinant of order 3. Now this is one of the most important part of this topic. We should be frequently, I think almost most of the sums we are going to use this technique of evaluation of specifically of order 3. So how I proceed to it? Before I proceed, I want to share with you something. Suppose let me write down the determinant of order 3. Okay, I am just putting across your point over here. So suppose if I say A, B, C, D, E, F, G, H, I. Okay. Now I want to evaluate this determinant. I will just explain to you, and then I will follow up with one example so that you understand how to. Very important children, I want you to focus it out properly. Okay. Now this is the order 3, 3 rows and 3 columns. So hence it is called determinant of order 3. But these are the elements of the determinant. I want to evaluate this. So what is the procedure is? Now for the timing, I want you to just understand this how it goes, and then I will just tell you exactly from where the signs and everything takes its change. So let us begin with this. So A, I am taking the first row. Okay, I am taking the first row as the base row. I am taking the first row as the base row and opening up the determinant. You can use any row, any column and open up the determinant, but there has to be some protocol, some sign convention which you have to follow. When you take the first row, it is always plus, minus and plus. So that is very important, keep in mind. And as if you take the first column or second column open, the determinant value remains the same, but the sign convention changes. Now what is it? As I go on, I will tell you. First thing is A into its minor. Now what is this minor? I will share with you. Leave this row and leave this column. See, A is in the first position. Are you understanding this point? A is in the first position. So leave this row and leave this column. What is left out? This is E, F, H, I. Now as I am taking the first row as a base row, so A into its minor, then minus B. I will come to that why I am putting minus sign. Later on you will understand it, but just right now just understand minus B into, now see B is in which column and which row? B is the first row and second column. So leave the first row and second column. What is left out? D, F, G, I. D, F, G, I plus. So plus minus plus plus C into, check what is left out. C is the third column and the first row. So leave the first and the third. What is left out? D, E, G, H. D, E, G, H, and then evaluate it. You know how to evaluate the determinant of order 2. Okay. Now, to just begin and make you understand better, I will give one example. Okay. Let us take a determinant. So, 1, minus 3, 2, 0, 1, 1, 2, minus 1, 3. Okay. I just took a determinant for you, and let me just show you how to evaluate this determinant. So, as scheduled, I am taking the first row as the base row and opening up the determinant. You can take any row, any column and open the determinant, but the sign convention of the first row is plus, minus, plus. So, if you see this here, plus, right, minus and plus. So, follow that same convention here. So, let us see how we go about it. So, first look at this pattern, which is equal to 1 into its minor. Now, what is the minor here in this case? Just understand what is the minor. 1, leave that row, leave that column. 1, 1, minus 1, 3. 1, 1, minus 1, 3. Right? Then, second, plus, minus, plus, because I am taking the first row and opening up. Minus of this. So, minus of, right? Minus of minus 3 into. Try to understand what I am doing. Minus 3 in the second column and the first row. So, leave the first row and the second column 0, 1, 2, 3. I think 0, 1, 2, 3. Similarly, plus 2. See what I am doing the sign. Plus, minus, plus. Plus, minus, plus 2. Okay. Then, you just put across the values. So, if I take the third column and the first row, 2 comes over here. So, leave that row and leave that column. 0, 1, 2, minus 1. 0, 1, 2, minus 1. Now, I can evaluate it very quickly. This is 1 as it is. So, this is nothing but AD minus BC. So, 3 plus 1. Minus of minus 3 is plus 3, right? 0, 2 ones are 2, minus 2, plus 2, 0, minus 2. So, finally, you have to just evaluate this. This is nothing but 4 minus 6 minus 4. Check it yourself, right? So, I think 3 1 plus 4, 3 2 is 6, minus 6 and 2 into minus 2 is minus 4. So, finally, you can get this 4 and minus 4 eliminates. So, the evaluation of this determinant is minus 6. Any row and column you can take as the base and open up the determinant. So, the convention which we follow while opening is this, that is plus, minus, plus, minus, plus, minus, plus, minus, plus. That means if you are taking the first column and opening up, it is plus, minus, plus. If I am taking the second row and opening up, it is minus, plus, minus. So, this convention I want you to remember, because this is something very, very important. We will be very frequently using in the other sums. So, I hope you got this point clear. Opening up the determinant, this is the convention, and how we apply it to numbers, this is the way you do it. So, you can just say this is an example for us. So, a lot of questions you will be doing on this. So, let us see how we can evaluate the determinant of order 3. Any row, any column you can take as the base row. This is the convention. Now, look at the, I took the first row. So, plus, minus, plus, plus, minus, plus. So, that is the way it has to do. If you take the second, it is minus, plus, minus. But the method remains the same. The sign convention changes depending upon whichever you are taking it up. I hope you got this point clear, children. Be careful, pause and note it down. No mistakes. You can understand it better, but when you write it out, you will do definitely some mistake. So, I want to be careful and just pen down this properly. Hello there. So, you had seen what is a determinant, you had seen how to evaluate a determinant of order 2, you are aware of how to evaluate the determinant of order 3. Now, one more small concept is there in determinant which you need to understand and know. What is a minor and cofactor of elements? of a determinant of course. So basically, before we proceed, I want to just educate you on this point. Now I am talking about an order 3, okay, order 3. So let us take the position of the elements. Now order 3, remember this is the first element, A11, A12, A13. So what does it mean? First row and first column, first row and second column, first row and third column. Similarly, A21, A22, A23, A31, A32, A33. Now please understand, this is nothing but the position of the elements. The position of elements. They are not the value of the elements, okay? So don't get mixed up. Now what I am going to share with you is the position of the elements is done, okay? Now I am talking about minor. Now let us talk about minor. Now before that I will just mention this thing, okay? Now what I will do is I will just write what is a minor in the fact. I will just show it to you, it becomes more easy for you all to understand. So let us take an element here, okay? Let us take an element here, a determinant I will give you, say 1, minus 3, 2, 1, 4, 3, minus 1, 2, 1. Okay. Now what I am going to do is, I am going to explain to you what is a minor of an element. Okay. So I will just take 4-5 examples, I need not put. For every element you get a minor. Now how I get the minor? That is what we are going to see. Now suppose if I want to find the minor of M11, M23, M22, M31, M33. Now remember 11, 12, 13, 21, 22, 23, 31, 32, 33. Now this is the position. So this is the position of the elements which is given over here. Try to understand. 1, 1. So first row, first column. So tell me, where is first row, first column? First row, first column is here. First row, first column. So this is 1, 1, M11. Okay. The minor is nothing but the determinant of order 2 except that element. Now what I mean by this, so M11 is this element. So don't consider this row and this column. So this is nothing but 4, 3, 2, 1. So remember this, don't consider this row and this column because it is present the first row and the first column out. So this is minor. Now how you evaluate it? AD minus BC. So if I see AD minus BC, 4 minus 6, answer is minus 2. So this is the minor of this element. So let us see the minor of the 2, 3. Now 2, 3, where are the position of the element? Second row, third column. This is first row, second row and third column. This is the element I am talking about. So its minor will be leave this row and leave this column. Where it is present, leave this row, leave this column. So what is the minor? So look at this, leave this row, leave this column. What is left out? 1 minus 3 minus 1, 2. Now you evaluate this, AD minus BC, you know. So AD 2 minus 3, because minus and minus is plus. So 2 minus 3 is minus 1. Let us take 2, 2. Now 2, 2, where is the element here? 2, 2 is over here, right? 2, 2 is over here. So leave the second row and second column because 4 is the 2, 2 element. So leave the second row and second. So what is left out now? Try to understand this. Second row and second column. 1, 2, minus 1, 1. 1, 2, minus 1, 1. Open up, same thing what you did before, that is AD minus BC. So 1 minus of minus 2 is 3. Now similarly let us go with 3, 1. 3, 1, can you tell me now 3, 1, what is 3, 1 is third row and first column. So third row, first row, second row, third row and first column. What is the minor of this? Leave this row and leave this column. So that is nothing but minus 3, 2, 4 and 3. So can you tell me what will be there? Minus 9, minus 8, right? Minus 9, minus 8. Minus 9, minus 8 is how much? Minus 17. Similarly, let us come to 3, 3. Now, if I see 3, 3, right, 3, 3 is here. So, 3, 3 is here, that is 4 plus 3, that is 7. Oh, sorry, I just wrote it out. 1 minus 3, 1, 4, answer is 7. So, what are these values? This is minor of 1, 1. This is minor of 2, 3. This is minor of 2, 2. This is minor of 3, 1. This is minor of 3, 3. Now, understand. So, I understood what is a minor. Now, I will tell you what is cofactor. You know how to find minor? You got the minor. I denote as M of any position. I am not worried. Okay. Now, what I am talking is, I am talking about cofactor. I am talking about cofactor. So, this is the minor here. When you put plus or minus sign to the minor, it becomes a cofactor. So, what is this plus and minus sign? If you remember, when I was evaluating the determinant of order 3, if you remember, I had explained you all plus, minus, plus, minus, plus, minus, plus, minus, plus. When you put these signs to the respective position of the element, it becomes cofactor. So, I just give you one simple example. Now, suppose cofactor I denote as A. Okay. So, A, say ij, ith row and jth column, just a notation I put, okay, which is equal to minus 1 raised to I plus j into m. This is nothing but the cofactor. So, sir, what is the big formula? Don't remember this formula. This is just technical part I am explaining to you. Let us see how I get the cofactor for this minor. Okay. Now, cofactor I am showing in pink, okay, and minor I had shown you into green. Okay. So, what is minor? Minor is nothing but the evaluation of the elements of the respective position, and cofactor is putting the sign to this minor. Keep that in mind. Cofactor is putting the sign to this minor. Have a note. Take this A11 plus. So, plus into minus 2 is, so this is the cofactor. I am putting in pink. Okay. So, cofactor is minus 2. Okay. Similarly, let us come to 3, 1. 3, 1. 3, 1 is which element here? Third row first plus. So, minus 17. This is the cofactor of direct, there is no change. 2, 3. 2, 3 is second row, third column. There is a minus sign. Right. So, minus of minus will become plus 1. That will become the cofactor. 3, 3. 3, 3 is there, plus, same thing. 2, 2. 2, 2 is here, plus, same thing. So, the cofactor is to the minor. Once you find the minors, you put plus and minus sign based on the situation. Now, every time I am not going to remember this, sometimes I get mixed up also. Simple logic I will tell you. This formula I will apply here directly. See, if this adds up to even number, it will be positive. So, plus of minus is minus. If it add to odd number, it is nothing but minus. So, minus of minus is automatically become plus. So, this is mean by minor and cofactor of the elements. I hope you got this point clear. Be careful, this we are going to see very frequently in determinant topic. So, I want you to just understand it and follow it up judiciously. I hope you got this point clear. Okay. So, we will continue with the next part of what is left out. You saw what is the determinant, you saw what is determinant of order 2, you saw what is determinant of order 3, you found the method of evaluation of determinant order 2 and determinant order 3, and finally the minor and cofactor of the element. This is the funda. We are going to visit this again, so don't worry, you understood 20% or still fine, no problem at all. We are going to visit this again and again in the sums. So, for the time being, pause and note it down. This formula is simple. Now, for example, like 2, 3, I will just make you clear. 2, 2, 3. So, actually it is 2 plus 3 is what? 5. So, minus raised to odd number is minus. So in short, instead of remembering this formula, there is no need to remember this formula. Just see if it happens to be 2 plus 3, 5 odd number, put minus. If it happens even number, put plus. That's the way it has to go. So I hope you got this point clear. So pause and note it down.